Hi everyone. In this video series, I will be focusing on the preprocessor module geometry details, the toolbars, and either it will be this one or this one. Both have no difference except the icons and etc. But before that, while I was looking at the previous video, I forgot about these um, work plans. It how work plans can be generated. So there are two ways to generate the work plans. The first one is 3 point, and the second one is the parallel work plan. So if we look at here, as soon as we um, select various points, we can see that we can generate the work plans according to our requirements, and we can work with the work plans according to what we can do with it. So work plans are important, and we can generate work plans according to our requirement. For example, if we select this point here, so we can select the origin, we can select the x-axis, and in this way we can generate the work plans according to what we are looking for. So this is based on the 3 points perspective, and this is based on the parallel. So for example, if I want to move it uh, offset of 50 and click on OK, it can be offsetted in this environment. So the thing is, work plan can be generated by mean of any choice. You can do whatever you want to do with it, and we can then play with the work plans according to our choice. After that, after work plans, you can further explore these in the documentation. So you can then work with it according to your requirement. So when you select a work plan and you work with it, then what happens is basically this work plan shift the global coordinate system and move it ahead before working with it. So then you can save them as well according to your own choice and work with it. After that, after work plan, let's go to the geometry module here. And in the geometry module, in the preprocessor module, we can see it is divided into 8 sections, and these 8 sections are visible here. That is exchange, edit, sets 3, 4, 5, 6, 7, 8, and every one have their own importance. And we can look at here; these are available here as well. So in the exchange section in the geometry main toolbar, you can find out these parameters and you can work with them. The first thing that is in the geometry module is import and export if you have any kind of modeling environment. This will be very useful when I'm doing practical projects on this. Um, I will find out that what is going on in this environment and how we can work on it. So the first thing is import and the other thing is export. If we focus on these import and export options, uh, we will be able to understand that what are the choices that the STKO is giving us to work with the files and how it can help us in making our modeling environment more easier. Well, if you have, for example, if you have a frame structure, a 2D frame or a shear wall, and you find it very difficult to create various sections in the modeling environment, and you want to use the import and export option for your analysis, is very easier for you. And other than that, it's both in the um, some options are both available both in the preprocessor and post-processor. So when you are working with the OpenSees, you should check them that what is going on in the model, what options are not available in post processor, and what could be the possible reasons of the non-availability or the absence of these file environments. So these import and export commands present under the exchange are a subset of geometry category, and geometries can be exported from or exported to external file. So, sorry, imported from or exported to the external files according to the documentation, and it will also gives us an opportunity to understand what file types can be interpreted in there, because outside, yeah, sorry, the OpenSees and STKO outside the STKO environment. So let's first click on the import environment here, import option in geometry. So after clicking on the import option, we are seeing here that we have these options available in the OpenSeas, that is IGS, IGS.stp, .step, .bref, and .rle. Honestly, if you are working with Python scripting, you will find them very useful, very useful in your modeling environment when you are exporting and importing these files. Because sometimes we have geometries that are not capable to be modeled using these options, and we have to take help from the third-party applications such as Rhinoceros, AutoCAD, Revit, and other files. And it become very easier for us to understand these in the beginning of the software inputs files. So and these are the supported file extensions, that is IGS, right? So IGS, and step file, and BREP boundary representation files, RLE, and it whenever we try to import them, so a regenerate model window will appear, which will shows us the power up converting these files quickly to our own requirements. So for example, I have this um, for example, these are the script generated files, and let's take steel tube. So this is the regeneration window that appeared here, and now I can see. Let's switch off the corners. Okay, I was discussing about the faces and the edges. So look at here. If I click on the faces hidden option, I told you guys in the previous videos that on an appropriate occasion, I will show that how these work. So these faces and these edges are now working. So if you have a line element, upon selecting the edges to hide and show, the line element will disappear. However, a 3D element will not disappear unless we switch off the edges and the other options. So this quite visible now, and we are now able to understand what's going on in the model. So let me switch off the view here, and after that, let's click on it to see what is happening in this model. So let's switch off this, right? And we have the steel tube, so we can rename it CFST steel tube, right? So it is giving us a geometry name option as well. That is, the software is using it, and we are able to understand now that this is the option that the software is able to understand, and it is able to use it. So after this, when the a geometry is imported, we can export it back to uh, any kind of file that we want here. So these are the supported file. So a best way to do is, to discuss it here is, if we are trying to understand these geometries, we are making it easier for ourselves that which file can be interpreted inside this STKO environment in terms of importing and exporting. And it's really easier for us because sometimes we need a lot of information outside the software, and it's a very easier approach to use it in this modeling environment here in this analysis. So just in case if you are trying to export it, then you have to go to the geometry and then exchange and then export, and it will be exported in the required format that you are looking for. So for example, I selected this, and after selection, if I select any region here, so I can write that file here, for example, exported file type, right? So that is exported in our analysis, in preprocessor. So we have these options that are available with us in the export module. Now, after that, we have this delete option. So when we select on the delete option, we can see here that the command in the backend is activated. This is delete geometry, right? And the history is visible here. We can look at here, and then it's showing us in the terminal which geometry or subshapes we need to remove. It's asking from us. So I will click on this, and as the command is activated, I will press enter. So that is deleted and the geometry disappeared, right? So this is how we can do it. Let's go back to the home and undo that deletion just to bring back that geometry for our ease. Now this is the option. In previous videos I discussed about this query tool here. So the delete is done here. Um, Whenever we select a geometry, we can get the information from it. If you are using any kind of other computer software such as ETED or SAFE, we get these information in the form of Excel sheets more easily as compared to these. However, when we are working with the finite element analysis models, we need them to be quickly checked inside the modeling environment without exporting these information to any third-party software format. So it's very good way to select it, and when we click on the query geometry from geometry and in the options here, it's both available here in this model environment window, as well as it is available here in the query geometry here in this way. So when I look at here, if I select on this window, a command window, it will be showing us what is going on in this model. So by query geometry, various options will appear. I showed them in the previous video in a discussion, in a detailed discussion as well. So this is the query tool, and if I click on it, right, this window appear here, right, and we can now work with it. So go back to the environment, select this geometry and query tool, and query geometry is selected. So select free edges and properties in all those options, so we can see this in our environment. However, the problem is we have not yet meshed this model, so we cannot work with it in this stage, right? And we cannot do this in this way. Uh, there are some ranges. For example, if I select this, for example, minus 100 to 100 by a range, right? and let's say 100 by 100, and by a range here, and then by volume range, 100 by 100. So if we have proper selection, then we can do this in this option. So we can then go to any edge, you can find out the center of mass and query vertex, and then you can select any point to work on it, and then this way we can get the informations here. Currently this is a not a simple shape but a kind of a complex shape. So some options that are available with us are already showing us in here in this property, while some options are not visible. We can go to select pre-spaces and add these environments to get area and other information from it, right? Um, so let's go back to this modeling environment here, and we can see now what is going on in this model. For this edge, we selected and we queried this, and we got this. For example, if I select this face, so it is asking me which face you are trying to consider. One is a solid element, one is the face. So I am interested in this face that is visible here, and I will query the area. So for the area, it is giving me these options. It should be noted that if you are working with this option, then you should be careful about the considerations, because the problem is it's not unit aware software, so you should use the proper annotations in your unit conversion. So that's how we do it. For example, if I again select this these spaces, right, and unselect all, I selected this solid cube and I query the volume, I'm getting the volume here, right? And for example, if I select this and I want to query the length, I got the length here. And if I want to center of mass, so for example, if I select this and I select the center of mass, I am getting the center of mass with all these components that are available here. If I select this and query vertices, then I should select the vertices and then click on it here. So we have these other options as well, and these are related to the sketches here. So I'm not going into make it more interesting, but the thing is, if I select the free edges, right, and then I go to query vertex, right, then we should select the other options. We don't have mesh here, so regarding to the mesh, we are not able to understand this, and that's why uh, we can do it. So we unselected this edges and these options, and now we have nothing to consider, right? These are the options. We can select the internal edges, we can select the floating points, right, and then we can query the area for it, query the volume for it, but we have not yet selected the solid. So if I select the solid, it's giving me two options. This is a face and solid, and then we can query the volume of this option. If we have mesh, I'll try to demonstrate this in the mesh module as well. So we can do this as well. Um, and the geometry selection, if you look at here, If we select an edge, right, then the the best way to consider is that when we select the red, we should look at the color notation here. It is turned to red. It means that the geometry that we have selected here is now under our consideration, and we can select them here. So after the selection of the geometries, we can switch to the properties tab, right? First you select it here. If I make it more simple, in this window it is your selection criteria, right? You should select these in your options. Let me unselect all. Let me try. I don't know the select by length range because I currently at this point I have no option to consider. The origin is not visible. Um, but if we have such kind of selection, then we can select them by specifying the range of this region. So this is 0, this is 1000, and if I want to select, and this is the internal faces. So if the internal faces are lying, okay, these are not lying. So if you look at the internal edges in this range, the internal ranges are lying. If we convert it to 0, select the floating, the free edges, the free spaces, all these are lying here. So this is the selection criteria geometries here. So once the selection is done, then we should switch to the properties module, and we can get the center of mass for all these faces. We can the edges for the faces for the mass, but we have not yet selected the mass for the solid, so we can do this. Query area can be done as well for all the faces. All these information can be obtained here, and we can do the same for all the other details here. While for the mesh info, if this geometry is meshed, you will be able to mesh it, and if the geometry is not meshed, then you will be able to sorry, if the geometry is meshed, we will be able to get the elements and nodes in all these queries related details, but if it is not meshed, we will not be able to get them. If we look at here, there are two ways to deselect the command here. First is to switch to any other option. The other one is to click on escape. So by double clicking on escape, the command will be deactivated. In this way, we can do the query tool here. After the query tool, we can switch to move, copy, rotate, scale, mirror, all these options. But I'm trying to make it more interesting by splitting these videos into a more detailed way of explanation. So I'll stop this recording at this point.